بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. Okay, my dear student, inshallah we are going to talk about the chemistry content for grade 3 or grade 12. Today inshallah we are going to talk about the first learning outcome. Let's talk about the fundamental laws of chemistry, and we are going to talk about the law of mass conservation, law of definite fusion, and the law of multiple fusion. Okay, this is our topic today inshallah. Let's start by this. Okay, firstly we are going to talk about the first concept in our learning outcome 1, fundamental of the chemistry. We are going to talk about the law of conservation of mass. This law illustrates that the mass is neither created nor destroyed in ordinary chemical or physical change. It means that the mass of the reactant it equal be the mass of the product. This is established by Anthony Lavoisier. Let's talk about the mass of reactant equal mass of product. An example: for the carbon dioxide gas or the simple one, magnesium react with the oxygen to give by the effect of the heat the magnesium oxide. If we return back to the mass, we'll find the mass number of the magnesium equal 24 and oxygen equal 16. By applying this rule, we'll find the reactant mass will be 2 multiply 24 for the Mg magnesium and 2 multiply 16 for the oxygen. It will be 48 plus 32 equal 80 gram. For the magnesium product mass, it will be 2 for the magnesium 24 plus oxygen 16 equal 2 multiply 40 equal 80 gram. It is the simple example. Let's talk about the another example. If we talk about the burning of the methane gas CH4 plus oxygen, the burning process, it giving to us any burning process for the organic compound, giving to us the carbon dioxide gas and water vapor. So let's assume that talking about the 16 gram from methane gas and 64 gram of oxygen. According the molar mass, the mass of the 1 mole, since when having a carbon by 12 plus the hydrogen 4 multiply 1, and for the oxygen we have 2 multiply 2, it equal 4 multiply 16, it will be 64. So if we will find that the product, it will be 44 according to the molar mass. For the carbon equal 12, and 2 multiply 16 for the oxygen, it will be 44. As we said, according to the law of conservation of the mass of the reactant, it will be 80 gram. So the product mass, it must be else 80 gram. So what is the mass of the water? So it will be 80 subtract 30 or 44, subtract 44, the mass of the carbon dioxide, giving to us 36 gram of the water. So from this we'll find there is no change in the mass is still constant. The mass of the reactant must be the mass of the product after the end of the reactions, but we'll find that only the rearrange between the atom or the formation of the bond. So if we talk about the bonds that broken, we'll find the 4 single covalent bond between the methane molecule and the 2 double covalent bond between the oxygen molecule are rearranged again to giving to us 2 double covalent bond between the carbon and oxygen compound and the carbon dioxide, and the 2 single bond between the oxygen and the hydrogen in the water molecule. It's only the change taking place, but the mass is still constant. This is about the law of conservation of the mass. Let's talking about the law of definite portion, okay, in next slide, inshallah. Next, from the fundamental law of the chemistry, we are going to talk about the definite portion law. It's established by Joseph Proust. It's talking about that, to explain this, it means that each element share in chemical compound by definite weight ratio. To explain this, let's talk about that example. Let's talk about the carbon dioxide. In this compound, we will find only one atom for the carbon. The molar mass of the carbon 12, and for the oxygen, when having a 2 oxygen atom, so it 2 multiply 16. Let's change this by gram. So if we said that 12 gram from the carbon, we'll find in the front of it, in the carbon dioxide, it will be the 32 gram of oxygen. If we multiply this percentage, if we said that when having a 24 gram of carbon, so we'll find only what is the mass of the oxygen. It will be cross multiplication, so it will be 24 multiplied 32 divided 12, it giving to us 64 gram. If we multiply this, if we said that we share by the 36 gram of the carbon, multiply it, what will be the mass of the oxygen? Else we will find the mass of the oxygen, it will be in this case 96 gram. But if we're making a ratio between oxygen and carbon in this compound, it will be 32 divided 12, it giving to us 2.76. And else in this, if we're taking the ratio between the oxygen and the carbon, it will be 64 over 24, it giving to us 2.67 else. And in this, if we're taking the ratio between the oxygen and the carbon, so it will be 96 divided 36, so it will be 2 else 2.67. So we'll find that each element share in the chemical compound by definite weight ratio, so the ratios between the oxygen and the carbon not to change. If we're changing the mass of that, we'll find the ratio it will be not change. So this is law illustrates that each element share in the chemical compound by definite weight ratio, and its masses or the ratio in the compound, it's not a change even we changing the masses of the reactant. Let's take an example or the problem on this law. An example said that a pure sample of sodium fluoride NaF contains, slide number 3, 35 grams of sodium. How many grams of fluorine in this compound? Firstly, sodium fluoride. Return back before solving this. We must return to the molecular mass or the molecular formula for this compound. So we'll find it will be NaF, the valency of this one and this else one. So it will be NaF. Okay, Na and F. We're making a table like this. Molar mass. The molar mass of the sodium, it will be 23. Return to the periodic table. And the molar mass of the fluorine is 19. If we have a 35 gram, what is the mass of the fluorine? We'll find it will be 28.9 gram. If we return back to the way or the method that you will find in the book, firstly we need to determine the mass of what? We need to determine the mass of fluorine. So starting firstly by known. So in having a 35 gram of sodium, if we use in 1 gram only from fluorine, and the molar mass of the fluorine, it will be 19 gram of fluorine. For the sodium, the molar mass of the sodium, it will be 23 gram of the sodium. So firstly we'll start by the given 35 gram of the sodium over 1 and the ratio or the ratio between the fluorine and the sodium. Why? To neglect sodium as a unit with the sodium. So it will be the mass, it will be else 28.9 gram. Any method you can use it. Okay, the last one we are going to talk about the law of multiplication, inshallah. Okay, law of multiplication, they're talking about this, or the assigned by the John Dalton. John Dalton said in this rule, when two elements for a series of compounds the ratio of masses of the second element that combine with 1 gram of the first element can always be reduced to small whole number. Let's explain. If I'm having a compound A, B, it will be AB2, AB3. For this, if we're taking the ratio, let's say making the ratio between A and B. So between A and B, it will be 1 to 1 in the first compound. Between A and B in the second one, it will be 1 to 2. Between A and B in the third one, it will be 1 to 3. Let's assume that making the ratio between the B in this compound and the B in this compound, between B and B, B versus B, it will be else 1 to 2. If we're making the ratio maybe مثلا P1 and B2, so B2 to B1, it will be 2 to 1, it equal to, it reduced to the whole small number. If we're making the ratio between B in the third compound to B in the second compound, let's start by firstly the larger, it will be 3 for this, over 2, it will be 3 over 2, it else can be reduced to the whole small number. Let's explain this by an example. According to the law of multiple proportional, we will find only the ratios of the second compound only, or the second element in compound are changed. Let's take an example. The example said that there are 100 grams of two different compounds. That are composed of sulfur and oxygen. The first compound contains 50 grams of sulfur, and the second compound contain 40 grams of sulfur. Show how this illustrate the law of multiple proportional. Firstly, we'll start to making the ratio between sulfur first compound, compound 1, the total mass of this compound would be 100 grams, and else compound 2, 100 grams, but the ratio it will be between the sulfur and the oxygen, sulfur and the oxygen. In the first one, we will find the sulfur 50 grams, and for the oxygen 100 subtract 50, it will be else 50. According to the law of multiple proportional, it said that the mass of the first compound, it will be 1 gram. So if we're taking the 1 gram from the sulfur, else it will be 1 gram of the oxygen. So the ratio between the sulfur and the oxygen, it will be 1 to 1, it will be 1. Look to the second compound. The mass of the second compound will find the 40 for the sulfur. From 100 it will be 60 for the oxygen. So if we're using the 1 gram from the sulfur, what will be the mass of the oxygen? It will be 1.5 gram. So if we're making the ratio between the oxygen and the sulfur to be reduced to the whole number, sulfur and the oxygen, sulfur it will be 1.5 and the oxygen 1, so it may be 1.5. It means that when we reduce it to a small whole number, it will be 3/2. So according to the law of multiple proportional, we'll find that the mass of the second compound, when it combined with the 1 gram of the first compound or the first element, it can be reduced to the small whole number. Okay, inshallah, next session, inshallah, my dear student, we are going to talk about the significant figures. We are going to talk about the accuracy and precision to ending the learning outcome. See you soon, inshallah, next time, and I will send to you the cheat to make practice on this part. See you soon, inshallah.